Hello students. So in first lecture we discussed about the calorific value and how to find out that calorific value. We discussed about the calorimeter, bomb calorimeter, Junker's calorimeter. Now in this lecture we will start with combustion and how to find out quantity of oxygen required, quantity of air required for the combustion of fuel. Clear? So in this lecture we are going to discuss about that for the combustion of fuel, how much quantity of air, oxygen required. Clear? So before that, this is the proposition. These are the uh, in air. Suppose we will take example of air. Now in air, according to mass, this is the percentage: 23.2 percentage oxygen and nitrogen percentage will be 76.8 percentage. So here we are neglecting some of the another gases. We are neglecting that. We are also neglecting the vapor, water vapor. So here we have considered only oxygen and nitrogen. So according to mass, this is the percentage. Oxygen percentage is 23.2 and nitrogen percentage is 76.8. Now according to volume, suppose we have 100 meter cube air. Now in that 21 meter cube will be of oxygen and 79 meter cube will be of nitrogen. If we will take 100 kg air, now in that 100 kg air we will have 23.2 kg oxygen and 76.8 kg nitrogen. So I hope you have understood this. Now after that, uh, suppose we have let us start with carbon. Now suppose we want to do the combustion of carbon. Now for carbon, how much air and how much oxygen is required, that we want to find out. So in that, first of all we have to write down the formula. We have to write down the formula. So according to this, we can see here that C plus O2 is equal to CO2. Clear? What is the molecular mass of carbon? That is 12, that we know. O2, O means 16, 16 into 2 means 32. CO2 means carbon 12 and oxygen 32 means total 44. So here we can conclude that for combustion of 12 kg carbon, you require 32 kg oxygen and output will be 44 kg CO2. Clear? But if you want to find out for 1 kg, if we want to find out for 1 kg, what we have to do? We have to divide all the value. Here we have to divide it with 12. Here also we have to divide it with 12 and here also 12. So by this we can get this 1, 8 by 3, 11 by 3. So here we can tell, we can say that for 1 kg carbon we require 8 by 3 kg oxygen and output will be 11 by 3 kg CO2. Clear? Now we all know that this is the quantity of air, but if we require quantity of this is the quantity of oxygen, but if we require quantity of air, what we have to do? We have to divide this with this. We have to divide this 8 by 3 with 0.232. So this is how we can find out the quantity of air required. Now we will write down the final formula. And how to find out the nitrogen requirement? So in nitrogen we can see this is the quantity of air, this is the quantity of oxygen. So if we will subtract oxygen from the air, so that will be our nitrogen. So here we can see, here In this formula I have written this is the quantity of air. Now we have subtract the quantity of oxygen, so we can find out the quantity of nitrogen. Clear? And ultimately finally we need to write down the formula, and this will be like this: 1 kg carbon require 11.5 kg air. Here we can see 11.5 kg air, and output will be 11 by 3 kg CO2, 11 by 3 kg CO2, and 8.84 kg, this is the value, 8.84 kg nitrogen. Clear? So I hope you have understood this properly. So same way, here we can write about the H2, H2, and product will be H2O. Same way, here we can also write down. So again, let us consider this combustion of hydrogen. Now here you can see that first of all you need to write down the formula. So formula also you do not have to remember, just you can make the formula. So here you can see, suppose H2, and what is our product? Our product is H2O. Our product is H2O, and oxygen, for oxygen we always write O2. So here you can see that H2 plus O2 H2O, it is not possible because here we have two hydrogen and only one oxygen. So what you can do? You can do this is how you can balance the formula. Clear? So here no need to remember the formula, just you have to balance on both the side, and this is how you can prepare the formula. So in this formula you can see that 4 kg hydrogen, 32 kg oxygen, and product will be 36 kg H2O. So for 1 kg, here we all know that we have to divide all the numbers with 4. So finally you can get 1, for 1 kg hydrogen you require 8 kg oxygen, and output will be 9 kg H2O. Clear? Now this is the quantity of oxygen, but if you want to find out the quantity of air, what we have to do? We have to divide it with 0.232. Clear? So this is how you can find out the kg of air required. And how to find out the nitrogen? I told you earlier that from the air you have to subtract the oxygen. So here you can see this is the air and this is the quantity of oxygen. So this is how you can find out the quantity of nitrogen. So again finally we need to write down the formula. So here you can see this is the final formula, that for 1 kg hydrogen you require 34.5 kg air, and output will be 9 kg H2O. So all taken from the formula, and output also will be 26.5 kg nitrogen. So I hope you have understood this. So this was about the mass analysis. And also another analysis I have written, that if from carbon, if our output is carbon monoxide, at that time what is the value of oxygen and air? So here also I have written this. Now we will discuss about the volumetric analysis. This was about mass analysis. Now in volumetric analysis we will start with this. So here you can see C plus O2 CO2. Now here you just have to write that 1. Here here we have only one carbon, here oxygen. So for that here you have to look the numbers. So here nothing is written, means it is 1. If nothing is written, it is 1. So here we can conclude that for 1 meter cube carbon you require 1 meter cube oxygen, and output will be 1 meter cube CO2. for 1 meter cube carbon you require 1 meter cube oxygen, and output will be 1 meter cube CO2. So it seems little bit complicated, but uh, according to Avogadro's law, this is the uh, this is basically according to Avogadro law. Clear? So now we know that for combustion of carbon we require 1 meter cube O2. Now what is the value of air? So for that you have to divide 1 by 0.21. So you will get this is the quantity of air required. Clear? And how to find out the nitrogen? From air, from air you have to subtract the oxygen, so you can get the value of nitrogen. So here also you can see final formula: 1 meter cube carbon, 4.76 meter cube air, output will be 1 meter cube CO2 and 7.36 meter cube nitrogen. So we will discuss more example so you can understand easily. Now here you can see 2H2 plus O2 is equal to 2H2O. So I told you that you have to just write down the number which is present here. Here 2 is there, that's why you have to write 2. Here nothing is written, means it is 1. So 1. Here 2 is there, so that's why you have to write 2. So for 2 meter cube hydrogen you require 1 meter cube oxygen, and output will be 2 meter cube H2O. Clear? So if we will divide it with 2, so finally for 1 meter cube H2 you require 0.5 meter cube O2, and output will be 1 meter cube H2O. But we want to find out the air. This is the nitrogen, this is the quantity of nitrogen, we want to find out the air. So what you have to do, you have to divide this with 0.21. So this is the quantity of air you can find out. Now from air, from quantity of air you need to subtract the value of oxygen, so you can find out the value of nitrogen. And finally you have to write the formula that for 1 meter cube H2 you have to use 2.38 meter cube air, output will be 1 meter cube H2O and 1.88 meter cube nitrogen. So I hope you have understood this volumetric analysis. So we have another volumetric analysis for this CO. So here you can see that 2C plus O2 is equal to 2CO. So here what is written? 2. That's why directly you have to write 2. Here 1, here 2. So 2 meter cube carbon require 1 meter cube oxygen, output will be 2 meter cube carbon monoxide. Now for 1 meter cube carbon you require 0.5 meter cube O2, and output will be 1 meter cube CO. Now to find out the value of air you have to divide this with 0.21. So this is how you can get the value. Now for nitrogen, from the air you have to subtract the oxygen. So from air you have to subtract the oxygen. So this is how you can find out the nitrogen. So final formula you all again have to write from this. For 1 meter cube C you require 2.38 meter cube air, output will be 1 meter cube CO and 1.88 meter cube nitrogen. So this was about the mass analysis and volumetric analysis. So I hope you have understood it properly. So thank you all.